Wildfires have many negative side effects, such as damaging the local ecosystem, decreasing air quality, and causing property damage. And they continue to become more common in recent years due to global warming and prolonged droughts. They also take an economic toll, as both the National Forest Service and the Department of the Interior have spent increasingly more on fighting wildfires in the past 40 years. Therefore, it's important to know how fires can be combated most efficiently. However, given the instability of wildfires, it's first important to understand how the local weather, which includes temperature, wind, and humidity, affect them. Therefore, my research question is how temperature, wind, and humidity affect wildfires, and how firefighters can use that information to combat wildfires more effectively. Using data from the GOES 17 satellite can help us answer this question. I decided to use the Caldor fire in California as a case study to demonstrate the use of GOES 17 data. The Caldor fire burned 221,835 acres of forest in the Sierra Nevada mountains during the summer of 2021, from August 14th to October 21st. It was the third largest wildfire in California that year and the second most destructive, costing $1.2 billion in damage. First, to analyze temperature, I used imagery from band 7 of the GOES 17 satellite, which analyzes shortwave infrared at 3.9 micrometers. This helps to show surface and fire temperature. This video was taken on August 17th in the early stages of the fire. As the video progresses through the day, you can see the fire grow in size as surface temperature increases. During the day, hotter temperatures and lower humidity increase plant transpiration and decrease soil moisture, making them more likely to become wildfire fuel. This is especially true in high elevation areas such as the Sierra Nevada, which show great fluctuations in temperature and humidity between the day and night. However, as the day ends and the surface cools, the heat the fire gives off, represented by an orange aura around the fire, becomes more visible due to a greater temperature gradient, signifying a greater heat loss. Also, notice that the temperature of the smoke plume extending northeast of the fire decreases significantly, going from a light orange to a dark yellow on the infrared imagery. All of these point to a weakening of wildfires during the night. In addition, to analyze wind, I use geocolor imagery to observe wildfire smoke patterns. Geocolor combines bands 1, 2, and 3 of the GOES 17 satellite, which measure blue light at 0.47 micrometers, red light at 0.64 micrometers, and near infrared at 0.86 micrometers respectively. It also combines band 2 of the Himawari 8 AHI satellite, which measures green light at 0.54 micrometers. Due to using visible light ABI bands, geocolor is ideal for observing phenomena visible to the naked eye, such as smoke. This video was taken on August 25, when the Caldor fire was approaching its largest extent. Throughout the day, you can see the plumes of wildfire smoke lengthen and thicken. This is partly because of increased wildfire strength during the day, as mentioned earlier, but also because of increased wind speed, as seen with the clouds moving faster towards the end of the video during daytime. Winds tend to be stronger during the day because as the sun heats the ground, it causes air near the surface to heat up and rise. This, consequently, lowers surface pressure and creates a pressure gradient that is corrected by more wind. This vertical air circulation also facilitates the spread of wildfire smoke to higher altitudes, where it can be spread further by faster, drier air currents. Winds are faster at higher altitudes because they are not obstructed by topographic features and because pressure gradients are more stark. Also, smoke particulates travel further in drier air because the lack of moisture prevents particles from clumping together, keeping them small and airborne for more distance. You can also see that there are southwesterly winds present the whole day, evidenced by the smoke being blown towards the northeast. We can also see the fire spread toward the northeast because of this, as new plumes of smoke can be seen developing at the end of the clip that weren't there at the beginning of the day. This is because wind causes wildfire flames to blow in the direction of the wind, causing wildfire growth in that direction. In conclusion, fires spread the most under high temperature, low humidity, and strong wind. Therefore, firefighters should take action in the early morning before sunrise when temperature is lowest and humidity is highest. They should also target the fire in the direction of the wind because it is the direction in which the fire is least likely to spread. My name is Win Young. Thank you for listening to this presentation.